Okay, so in this lesson, we are rationalizing a radical. All right, you can see it written down there. I'm not sure why, but it is against math rules to have a radical in the denominator. To get it out, this is called rationalizing it. Okay, so if both numbers are on a radical, you want to see if you can reduce the fraction first. All right, so I've got square root 27 over 3. I can reduce that, because 27 divided by 3 is 9. Okay, well, the square root of 9 is 3. I can do that. And I no longer have a radical in denominator. Well, on this one, as long as they're both the same index, both square roots, I can divide as if they're under the same radical. Well, 250 divided by 10 is 25, and the square root of 25 is 5. I no longer have a radical under the denominator. Okay, but sometimes we can't do that. 3 is outside of a radical and 2 is inside. So here's how we rationalize. We multiply by a really screwed up 1. Whatever is in the denominator, that's what we multiply by. Bottom and top. This is what I mean by a really screwed up 1. Anytime you divide a number by itself, it's a 1. Okay, so when I multiply a 3 by the root 2, that's 3 root 2. When I multiply a root by itself, okay, that's root 4. Well, what is the square root of 4? Okay, it's 2. So as long as you don't have a radical in the bottom of your fraction, you are good to go. Now, I didn't have to simplify on root 2 because root 2 is already reduced. But root 12, I gotta fix that. We've done root 12 a couple of times. Remember, that was 4 and 3. Square root of 4 is 2. So to get the radical out of the denominator, you multiply the top and bottom by the radical that's in the denominator. Just the radical. So in this case, just the root 3. And this is why we do multiplication first, because root 5 times root 3 is root 15. And root 3 times root 3 is root 9. Well, the square root of 9 is 3. So this is root 15 over 6. All right, simplify it as much as possible. Can't do anything with 6, so it's already out of the radical. 54, the largest square that goes into 54 is 9. And the square root of 9 is 3. So the root that I multiply by is root 6. So multiply 6 by root 6. And root 6 by root 6. And the square root of 36 is 6. 6 goes on itself. So radical 6 over 3. Now this does not simplify, because it's not really a 6. It's the square root of 6, which is 2.4. Okay, so it's not divisible by 3. So this is the final answer. All right, simplify. Remember to divide the exponent by the index. But you do have a remainder, so the y is going to stay underneath. Now I'm going to simplify again here, using our laws of exponents. y1 over y2, so 1 is the smaller exponent. Now the root we want to multiply by is root y. Top and bottom. Okay, well, again, we have this root going on here with the exponent. So exponent by index. And that's as far as I can go. Okay, if you can't simplify, you go right into multiplying. And the root we want to multiply by is the root 6. So multiply across the top. 2 root 5 times root 6 equals 2 root 30. Root 6 times root 6. At this point, I want you to see that when I multiply radical by itself, the radical drops. Okay, and then I'm going to reduce. The 2 and the 6 can both be divided by 2. And then we want to check the 30. It's not divisible by anything, so we're actually just going to leave that by that. It's not divisible by a square, I should say. Okay, so let's simplify. Largest square that goes into 45 is 9. Square root of 9 is 3. 5 and y, since y has an index of, or an exponent of 1, I can't divide it. So that is the root I want to multiply by. Multiply inside your radical. Remember, when you multiply a radical by itself, the radical drops. $35 doesn't have anything, so that's it. All right, we want to simplify. Largest square into 18 is 9. And I can't really do anything with the x. Square root of 9 is 3. This has a 1 for an exponent, so we can't simplify it. So that is the root that I'm going to multiply by. So that is going to give me root 10x over 3 times 2x, which is 6x. Again, we need to be careful. If it's under the radical, it's not really a 10x. Okay, it's protected by the square root symbol, so I can't just reduce from there. And then definitely want to reduce on that one. Divide the exponent 7 by the index 2. So that's an x cubed, but you do have a remainder of 1. And that's exponent 1. Use your laws of exponents, make it easy on yourself. Your root x is what we multiply by. This is x squared times x cubed.